from the origin. So what is the question? At t equal to 0, the charged particle is given velocity v bar equal to v naught j cap in a region that consists of E bar and B bar as shown. Okay, find the trajectory of the particle. Find the parameters of trajectory of particle. Some electric field we have brought it. Oh, everyone is able to understand. You see this. Here, let me write E bar. That'll be more meaningful. I want that we know electrostatic field. Don't bother about the magnetic field. No, only electrostatic field. Will it exert any force on the charged particle, or only on the charged particle? If it is in motion, it will exert force. Electrostatic force will act on the particle only if the charged particle is in motion. When the charged particle is at rest, it will not act. Is it anything like that? Nothing, no. Whether charged particle is in rest or in motion, electrostatic force will act. The field, electrostatic field will exert force. What about the magnetic field? Magnetic field will exert force on the charged particle only when the charged particle is in motion. I think this is the very primary thing which we are supposed to consider here. Okay, let's analyze now what that electric field will do. I think the previous problem, this problem are related. So this electrostatic force, what it will do? It will continuously increase the velocity of particle along x-axis. Then this electrostatic field, can it change this V naught initial component projectile motion? If you project horizontally, that weight, will it change horizontal velocity? No, even when the object is striking the ground. The biggest problem is like what we studied, we don't know how to apply. I say I'll project it with a velocity u naught. Then when it's striking the ground, what will be this u naught? Will remain as it is. No, only the y component will keep on increase. Tell me what will happen to this v naught, y component of velocity? Will never change, no? This electrostatic field will never change it. So therefore, this v naught will be responsible for what? Like circular path. And what did electrostatic field do? Will accelerate the charged particle along x-axis. Previous problem, it was uniform velocity motion along x-axis. Now, this particular electrostatic field will make the charged particle to accelerate along x-axis. So therefore, the path of the particle will be, I need some reference line, then I'll erase it. I'm showing the distance, keep on, it increases. Okay, look at the pitch now. The pitch will continuously increase. The reason, because of electrostatic force acting on it. So whatever the find the parameters is asking. So first we have to calculate the radius. Radius of helix. We'll ask several things here. Radius of helix will determine only the V naught component. Radius of helix is equal to mv naught by qb naught. What about the time period of revolution? Anybody wants to answer? I really want from students. I'm waiting. Time period of revolution.
By m by cube naught.
Let's all know it is independent of speed of projection, whether water be that one, 2 pi mv naught. So the time period of revolution will be same as it is. Then okay. 2 pi m by bq. V naught will not come into picture. Okay, I think this will become, this has made problem very easy now. Nothing to, we need not to bother anything. What about the x coordinate, y coordinate? X coordinate will get the position vector. So what's happening to here is going to describe a helical path with increasing pitch. What is it this here? Helical path with increasing pitch. The pitch continuously increases. You see this distance. Fine. Huh? So the pitch is continuously increasing. Okay, let's do one thing. Let's calculate the position vector. Xi cap plus yj cap plus zk cap. So what shall I write x here now? Shall we write u cos theta t or any other thing? No, it should be like a q e naught by m t square I cap. From where this q e naught will come? X equal to half at square. What is the acceleration along x-axis? I'll write one more step. What is the acceleration along x-axis? It should be equal to, this is not needed, no? Yeah. We will write all these things. Ax equal to q e naught by m. And then what about y coordinate? What to do? So here again you take help of the earlier diagram. In y minus z plane, what should be the trajectory of particle? Now I'll look at the chart. Just wait. Let me wind up this. After some time t. This is for y minus z plane only, but it will have x component will keep on increase. This is r, and the magnetic field here will be b naught out of the plane. Hope it's going to describe a circular path in y minus z plane. This is position vector. Okay, yeah. I'll make changes. Again, shall we write the same thing? Earlier equations, what we had, only x coordinate is what I should change, no? Only x coordinate is what I have to change. So shall I dump the same value r bar? This quantity should be as it is. Only x coordinate is going to change. But here theta, what is theta? Will you agree this sine theta or cos theta? Theta is in fact 0, no? So shall we put this 0? I think here the big headache will come. Because we will determine the radius. Radius is given by m v naught by qb. That's all. I think I didn't write radius. Here it is there, no? So therefore this should be, let me write it, r. This should be r. Later on, what is r will substitute. Hope you are able to think the way What is R? R will substitute all the values. So this will become QB naught sine B naught. Okay, here we have changed it, B naught. This is a general idea a student must have. Similarly, I want the velocity vector. What about the velocity vector? Velocity along x-axis should be equal to ax into t. Velocity vector v naught. V naught should be equal to v naught. This is again from earlier what we did. V naught cos phi. This should become, cos phi should become equal to omega t j cap. What is omega? Omega, I should write it as bq by n. What is ax further? Ax will become q e naught by m. We should get ready ourselves with the basic theory. Then we can go for application part. Okay, are we sure now how to find out the velocity vector of any point S? Do we know how to calculate the position vector S? Then okay, yeah. See, the complete description is available. So can you show sir that R bar? Yes, it's there. What is there? That one simple. Here, this will be R bar. We can point it. Position vector of particle at any time t. Velocity vector. So here also we'll bring the velocity vector somewhere here for our convenient V bar. Like this, the velocity vector, position vector of the particle at any time t, we are able to predict. Radius of helix is not going to change. That's why I brought that horizontal line. I'll remove that. Now look at the pitch. Pitch is going to increase. So therefore, what we can say, helical path with increasing pitch. Now I'll ask you one primary question. Speed of particle, will it increase or decreases? Who will answer this with the time? Speed of particle will increase or decrease? Speed of particle will it increase or decreases? Nobody's answering. You know electrostatics and you know now motion of charged particle also. You have to combine both to answer that. Speed of particle increases or decreases with the time? Speed of particle in fact increases with the time now because of acceleration. So now I want like with the time, after what time the speed of particle will become 3v naught? Can we find out? Find the, in the above question only, find the time after which the speed of particle will become 3v naught. Okay, this I'll bring this as a part A. Part B I'll introduce. Find the speed of particle. Find the time at which speed of particle become 3v naught. Shall I get into the question? No, because I have to write question here. Find what is the part B? The speed of particle. Find the time. Becomes equal to 4v naught, we'll write. Find the time at which the speed of particle becomes equal to 4v naught. Speed will continuously increase. I want that particular time. He's asking only the time. I'll take help of this equation only. I'll take help of this equation only. He's asking the time. Sir, what to do here? What will happen to speed of particle in YZ plane? At any instant will remain V naught only. X component of velocity will be continuously increasing. Oh, everyone, you know so much of kinematics. The speed of particle, what is V naught? V naught is the speed of particle in YZ plane. It will remain same. X component of velocity will continuously increase. Agreed? So therefore, what should be the this expression now? Now it will be like, I'll go back to the very first one. Vxi cap Vy root of Vy square plus Vz square is what? V naught square. Hope if you can agree this, everything will be in a better place. Because what is the thing? Speed of particle in Y plus or minus, okay, you want, okay, that also I'll include in plus or minus YZ plane remains constant. Because how the electrostatic field will act perpendicular to Y minus Z plane, YZ plane. So therefore, the speed of particle V naught, the speed of particle in YZ plane remains constant. And what is the speed of particle in YZ plane? It should be V naught. V naught in YZ plane remains constant. So I think the problem has become very simple. V square is equal to Vx square. I will group these two. So do we know value of Vy square plus Vz square? That should be equal to V naught square. Okay, this square term should not be there, or under root should not be there. Yeah. Time after which the speed as will become 4V naught. So therefore, given 4V naught. So therefore, this will become 16 4V naught whole square. What about Vx? I should write Q E naught by 2m into T. So this will become 17 V naught equal to Q E naught by 2m into T. So what is the expression for time? T square. Okay. T square will be the yeah. So this will become 34 mv naught by QE naught. This will be our answer. Okay, I say some we may find suddenly shocking, like, sir, how nothing is that. Just we have to bring out basics of circular motion, other things. $15, 16 minus. Okay, yeah, I'll like to improve my maths. 15, I'll make changes. Now, after this, when the particle crossing the x-axis, okay, just we once, I'll go for the next part of the discussion. 30, somebody's telling 30. Oh, yeah. I'll make changes. 30. Yeah. I made changes 30 MV naught. We can't do anything. I use formula for displacement. Okay, I'll make changes. I don't know. I have to cover one more topic. I'm getting deviated because of that. Okay, fine. So this will be 4v0, and I'll do it fresh. 4v0 square. This should become axt whole square. Yeah. This will become v0 square. So this will become 16v0 equal to, this will be q e0 by m. This is t. (15v0 square equal to q e0 t square. So t will become mv0 by q e0 under root 15. I think that I am now, this time I'm very much correct. This will be your answer. Dimension also now it is correct. Okay, this is, I'll go for the next one. One more thing. So if you look at the, when this particle crossing the x-axis here, how the velocity vector will all the time, will it be oriented in same way, or at different instance it'll be at different time? So this is the, I think if I go for the putting, this is a t equals 0 we have projected. After some time t, it is here. Only capital T I'll write it. This will be 2t. After every one revolution, it will cross the x-axis. So what is the x coordinate? Already we are given x coordinate. Okay, we can find out. Whatever the velocity vector, every time will it cross the x-axis with the velocity directed in same way or different way? So you look at this one. When it's crossing the x-axis, v0 will remain same, but the x component of velocity will keep on change. So here I will give one more. This is very important. So here, if you see this is the x-axis. We'll bring the idea like this here. At t equals 0, how the velocity vector like this. After one revolution, v0 will be there like this, but the particle velocity will slightly get inclined. Then next, after one more revolution, I'll bring this a little bit closer. And the magnitude also should increase, no, with the time. Then after one revolution, the angle of inclination little bit more. And the magnitude of velocity vector also should increase. You see this, and this is the x-axis. Will I agree? Because x component will keep on increase. X component of velocity will keep on increase. In general, if you look at the thing, it will be of like this. The resultant velocity. The angle made by it, I'll call beta. This beta, will it be a constant? No, beta will be continuously. Earlier 90, it keeps on decreases with the time. So this is at what time? T equal to capital T. 2t, 3t, 4t. After n revolutions, it will become nt. So then after n revolution means what is the expression for velocity? So we'll write tan beta is equal to v0 by vx. V0 as it is. What is vx equal to? Ax into t. Ax equal to q e0 by m. What is this t? N capital T. So this will become mv0 n q e0. What is the time period given by? 2 pi m by q b0. So this will become b0 v0. Q get cancelled, m get cancelled. So therefore this will become 2 pi e0 n. Look at this. As n increases, what are the values of n? N should start with 1, 2, 3, 4, 5, and so on. So the beta correspondingly will decrease, and the magnitude will keep on increasing. That's why I'm indicating the vectors with increasing magnitude. After one revolution, the particle will be here. After two revolutions, after three, after four, the velocity vector at the instant when it is crossing the x-axis, the orientation of that, it has to keep on changing. After a long time, how the velocity vector will be almost along x-axis for a very large value, when it will be n equal to infinity. So what will be the helical path? Means the helical path which we are drawing, I think we have to be careful now. You cannot draw all the time this vertical. So here, this part of the curve should get more and more inclined towards x-axis. Oh, getting? So that's what I meant. And you see that earlier it was almost vertical. Now, look at this. Look at this. Look at this. Next part here, you see this. Able to understand? Now, if you remove this E naught, then no problem. Every time it will cross with a velocity perpendicular to z-axis here. Because of this electric field, as the velocity vector will keep on getting inclined. The inclination towards the x-axis will keep on decrease. That's what I'm trying to show here. I think the problem just not mere equations. We must make a very good observation of things. So what is beta? So how you define beta? Angle made by velocity vector with x-axis at an instant when it is crossing